everyone, we're going to use the principle of mathematical induction to show that the given statement is true for all natural numbers n. This is a more advanced problem, and I'm going to go through condition 1 and condition 2, assuming that you know what those are. If you don't, you need to watch some of the easier mathematical induction problems first. Okay, so condition 1 means we're going to check for n equals 1. So I'm going to plug 1 in to my sum here. And this gives me 1/3. And this should equal my first term, which is 1/3. So that checks. So for condition 2, we assume it works for some k. So I'm going to write this with the k in it. 1 over 1 times 3. Plus 1 over 3 times 5, plus 1 over 5 times 7, plus dot, 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 plus 1 over, now we're going to use k, 2k minus 1 times 2k plus 1 equals k over 2k plus 1. So if it works for k, then we're going to check to see that it works for k plus 1. So that's condition 2. So I'm going to write this again. We have 1 over 1 times, this is times 3, plus 1 over 3 times 5, plus 1 over 5 times 7, plus dot, 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 plus 1 over 2k minus 1 times 2k plus 1. And now my next term is going to be 1 over, and what we're doing here is I'm going to look at this one right here so I don't mess up. I'm going to look at this one here. You take, and I showed you all this in another video. The slope of this line here is 2, so I'm just going to add 2 to this. So we're going to write 2k, and negative 1 plus 2 is 1. All right? Same thing here. If I add 2 to the 1 here, my next term is going to be 2k plus 3. So this is your next term. Now, for our sum, we get equals k plus 1, and then I'm going to add the 2 here from here, and you get 2k plus 3. All right? Now we're going to go ahead and simplify this and check. We know that this statement here, which is this line here, equals k over 2k plus 1. So I just substituted, and now I'm going to add my new term, which is 1 over 2k plus 1 times 2k plus 3. All right? And this should equal the right side, which is k plus 1 over 2k plus 3. So on the next slide, I'm going to copy this down again. So let me do that. We get k over 2k plus 1 over 2k plus 1 times 2k plus 3. Now, I need the common denominator. My common denominator of this is this piece right here, because this is already included in there. So we have 2k plus 1 times 2k plus 3. Now, to get the common denominator for this first piece, you ask what times this old denominator here gives you the new denominator. And what you have to multiply by this to get to make it look like the new denominator is 2k plus 3. So we're going to multiply my numerator by 2k plus 3. And you can see if these two canceled, you would get back to the original. Now my second term here, I ask myself, what do I multiply by this denominator to get the new one? And it's just 1, because it's the same denominator, so you get that. Now let's clean up the numerator. We get 2k squared plus 3k plus 1 over 2k plus 1 times 2k plus 3. Now I'm going to factor the numerator, and when I do that, I get k plus 1 times 2k plus 1 over 2k plus 1 times 2k plus 3. Now these two cancel, and we're left with k plus 1 over 2k plus 3, which if we look back here is what we wanted. So therefore, we have proven, which is what had to be proven, which is what that means. And condition 1 and condition 2 have been satisfied. Therefore, the statement is true for all natural numbers n. Thank you and have a nice day. Bye-bye.